Module 3, Lesson 6, Dilations on the Coordinate Plane with Mrs. Richards. Today we are going to talk about what to do with individual coordinates and also what to do when they are on the graph. So we're going to start on page 26 of Module 3 today and begin with a couple of exercises, the first 5. So we're going to start here with Exercise 1, and it says point A equals 7, 9 is dilated from the origin by a scale factor r equals 6. That's important information. What are the coordinates of point A prime? Well, to get that, we would multiply each of our coordinates, 7 and 9, by 6. So A prime, 7 times 6 is going to give us 42. And then comma 9 multiplied by 6 is going to give us 54. And so that is our new coordinates. Basically, to dilate a coordinate by a scale factor, what we do is we multiply each individual coordinate by the scale factor, no matter what it is. So in our next one, point B is at negative 8, 5. And is dilated by a scale factor r equal 1/2, what we do to find b prime is the same exact thing. We would do negative 8 times 1/2, and we get negative 4. And then we do 5 times 1/2, and we get 2.5. Now, in your calculator, many of us know that 1/2 is 0.5, so we can use the decimal. Otherwise, in a calculator to multiply by a fraction, your best bet is to use a parenthesis and then do our numerator divided by our denominator in the parenthesis. So when you were to type that in, you would literally type negative 8 times parenthesis 1 divided by 2 and parenthesis equal, and out would come negative 4. And as we roll down the rest of our exercises here on this page 26, we get similar answers where we are just coming up with a new coordinate. So if I slide this guy up a little bit, point C dilated from a scale factor of 3/4. Well, 3/4 is our scale factor. C prime then. 6 times 3/4 is going to give us 4.5, comma, negative 2 times 3/4 is going to give us negative 1.5. And the rest is very similar, just multiplying. The whole idea is we multiply our scale factor by both of our original coordinates. Now, the second thing that we need to go over in this lesson 6 is on page 27. So aside from just being able to multiply coordinates when they're given to us, sometimes what we have to do is be able to identify the coordinate first and then multiply it. So I want to point something out on here. And that would be how to read our question to tell us what exactly they're looking for. It tells us in here the coordinates of triangle ABC are shown on the coordinate plane below. The triangle is dilated from the origin by a scale factor of 12. That's important. Identify the coordinates of the dilated triangle. So identify the coordinates is all it says, so it doesn't say we have to plot them back on the graph. So what we're going to do is find our original coordinates A, B, and C. So A is at the spot negative 2, comma, positive 2. B is at the spot negative 3, comma, negative 3. And C is at the location positive 6, positive 1. And it tells us our scale factor is 12, so we're going to multiply all of our numbers by 12 to get our new coordinates. So, and I'm going to put them over here. A prime would be negative 24, comma, positive 24. B prime, if I multiply both of these by negative or by 12, would be negative 36, comma, negative 36. And finally, C prime would be 72, comma, 12. And this is how we leave our answer, because even though there is a graph available, it doesn't tell us that we have to plot our points back on there. And even if it did, we know there would be a problem because our graph is not big enough to put 72, 12, or even our lowest number, negative 24, positive 24, on it. And so that's what we are looking for. The last question that we are going to go over in the lesson today is on page 28. So if we turn the page. And this is the one that, as a teacher, if I'm grading this question, is worth the most points. So we're going to read through it and talk about what we have to do. Figure DEFG is shown on the coordinate plane below. The figure is dilated from the origin by scale factor r equal 2/3. Identify the coordinates, so same words again, of the dilated figure D prime, E prime, F prime, G prime. And then draw and label figure D prime, E prime, F prime, G prime on the coordinate plane. So not only do we have to identify the coordinates, we also have to put them back on our graph, draw them out, and label them. So what we're going to do here is, again, we're going to start by finding our original coordinates. And I'm going to show you on the calculator this time, since we're using our fractions, what I mean by using the parentheses. So point D right now is at negative 6, positive 3. Point E is at negative 4, negative 3. Point F is at positive 5 and negative 2. And finally, point G up here is at negative 3, positive 3. Now, we're going to multiply all the numbers that we just found by 2/3. And I want to show you on the calculator here what that looks like for any calculator that has the scientific calculator. Some of them, mine, have a fraction button, but I want to show anybody what they can do if you don't have the fraction button. So we're going to start with negative 6 times the 2/3. Negative 6 times, and we want to do parenthesis, 2 divided by 3, end parenthesis, and that's how we do it. So our D prime is going to be negative 4 will be our first answer, comma, and then we would type in 3 times 2 divided by 3, and we get 2. And that's how we get our ordered pairs using our calculator. Now, these came out nice whole numbers. However, some of them won't come out to be whole numbers. So, for example, if I do the next negative 4 times parenthesis 2 divided by 3, I get negative 2.6 with a 7 at the end. Note that these calculators will round at the end. They're just saying that's all the space I've got. We can write that here as negative 2.6 with our repeat sign on it, comma, and negative 3 times 2/3 would give us negative 2. I know I'm not typing that in to save some time here. F prime, if we do 5 times 2/3, we get 3.3 with the repeat sign, and then again negative 2 times 2/3. We will get another decimal, negative 1.3 with the repeat sign, or negative 1 1/3. And finally, G prime, if we had typed that in, negative 3 times 2/3 is negative 2, and 3 times 2/3 is positive 2. Okay, and so we end up with all of these answers here, and that's 4 of our points. Well, then that's the identify the coordinate part. The next part is to draw and label each on our graph above. So I'm going to actually slide this up so that I can show you where all of these are. Or I'll slide it over just a little bit. And let's talk about, so negative 4, 2, here's D prime. That's a nice, easy one. G prime's also pretty easy right here, negative 2, positive 2, sorry, wrong way. And those are nice integer ones. The ones where we have to struggle a little bit would be E prime and F prime because we have to estimate where they go. So negative 2 is here, 0.6. So 0.6 repeating is going to be a little bit beyond half. So you're going to estimate where that is and then down 2 from there. So that one's going to land still on a line, but not on a cross there. And the one that lands on no line at all is our F prime, 3.3 repeating. If we go over 1, 2, 3, and not quite halfway here, and then down 1.3, we're estimating again. It should end up kind of in that top third, but not touching any of the lines because they're both decimals. And so here's, oops, I'm sorry, not G prime again. This was F prime. And then you want to reconnect all of your dots here. And you should end up with a similar figure to the original, only shrunk down by a scale factor of 2/3. Okay, that is it for our short little lesson today. For my class, your assignment is to do page 30, numbers 1 through 5, and I actually think it is pages 30 through 32 is what the stretch is. If you have questions or concerns, please see me before class or during team time, and I can answer your questions as needed.